Hello everyone. Today I'm going to explain about string matching algorithm. My name is Sachin. In problem definition is finding one or more substring inside a longer substring is known as string matching. And I'm going to explain about length of end and m. These are the pseudo codes for Naive string. And the runtime analysis would be nm. In experiment description, I'm going to take 10,000 to 1 lakh characters with increment of 10,000 characters. These are the tables for computing C. And now I'm going to explain about the code. In this code, I'm going to take about Navy string matcher. Here I'm going to implement algorithm as a comparison. Algorithm works by comparing P with substring of T of same length as P. Starting from leftmost of substring, if a match is found, the starting position of a match is printed. The code first calculates the length of T and P. It iterates every possibility of a substring. It checks if it is possible or not. So I'm going to run this code, and this is for the KMP. So this is a sample input output, and I'm going to get as this is a sample input text and pattern. And here I found 0, 1, 9, 13th positions of this pattern in the text, same as in the KMP matcher. This is the second um, sample text, and I found only once, that is in the 10th, so that it appears at 10, so output is 10. And these are the simple output and input. And now I'm going to explain about KMP algorithm. KMP algorithm contains a compute prefix function and KMP matcher with parameters of T and P that implements the algorithm for string matching. The compute prefix function takes as input pattern string P and return as list pi, where pi square q is the length of the longest proper prefix of p0 not plus 1. That is also suffix of 0 of plus 1, which is used to construct a failure function of the table. In KMP, matcher function takes a simple input text P and P, finds all the occurrence of T using the KMP algorithm. The functions they compute the pi of P using compute prefix P. Then it iterates over the character of P, and it uses the failure function of table pi to determine the next position to character. If the character matches, it updates the current position Q, and if Q equal to length of P, it prints the index of occurrence and updates the Q using the pi. So this is the KMP algorithm, and these are the sample input output for both the Navy string and KMP algorithm. And here is the average code, average analysis. Here is the output. Here I am calculated 10,000 inputs for the average time of Navy algorithm is this one, and for 10,000 KMP algorithm is this one. I'm going to use the same functions for computing the this average runtime. So here I took the random inputs of for text, so it will be running for the Navy string matcher and total runtime for the both KMP matcher and Navy string matcher. So it takes the same text and pattern and gives the total runtime, and we are going to find the average for both Navy and KMP. And I am going to also plot a graph by using the plot runtime functions for comparison of the runtime for both. So this is the output of the above code. Here I calculate all the average runtimes of both algorithms, and this is the graph for the both runtime analysis. So here we can see KMPE algorithm is much efficient than Navy algorithm.